Okay, gentlemen, today taking a look at factoring. Those of you that have seen it before, this is a good review. Those of you that have not, let's make sure we pay close attention so we get the hang of it. We will be doing this for a while. So if it is, if it's not super clear right in the beginning, we're going to be spending a lot of time on this, so it should fall together pretty good. I don't have a printout of notes because the notes I have are a little bit involved, and I don't want to have to scroll down to page 7 to kind of start with this stuff. So blank notability sheet, open this up, factoring. Okay, so just kind of a review of some things that maybe like the easier definition of what it means to factor. A lot of times when I was a student, I did things I didn't really know exactly what I was doing. So if we were to say that what are the factors of 6, that was one of those thinking problems I gave you in lab. I may not have done it to every class yet, but a couple of classes I gave this to. What are the factors? And I said like 2 of them subtracted or equal to 2 of them added. So the factors of 6 would be like what multiplies to get me 6. We had done this with radicals as well, where we were trying to get prime factors in order to get some of my prime numbers to come out of the radical and then the ones that stayed in. But an example here would be 1 times 2. Well, I'll do it like this, like 1 times 6 or 2 times 3, right? Those are 2 factors, 2 groups of factors. Okay, a lot of the things we're going to be dealing with now would be kind of like simpler, where the factors of something like 3, right? There's only 2 numbers that multiply to 3. It's 1 and 3. And if you kind of take out the 1 in itself, like these are the answers. If I say don't include 1, give me all the other factors. Like that's what we're looking for. These types of polynomials we're about to give you, where when we factor them, we're going to get prime answers. Like the factors of 6 or 2 and 3, those are my prime ones. Those are the ones I want. Similar, if I were to say what are the factors of something larger like 24, there's more than one answer, but we're always going to get down to as simple as we can. So something like 12 times 2. You would say, okay, those are factors of 12, right? But I may want to bring that down and say, what are the factors of 12? Well, that's 4 times 3 times 2. And just like we were doing with radicals, look, no, break it down more. Get down as prime as you can. 2 times 2 times 3 times 2. So you see all my parentheses here just to kind of show what's being broken down. I chose 12 and 2. 12 is 4 and 3. 4 is 2 and 2. But these are my prime factors. Just like we had with radicals, prime factors would be 2 times 2 times 2 times 3. And if this were in a radical, a cube root or something like that, I would decide what I take out of the radical, but not here, right? I'm just saying, what are the factors? And we're using this idea to move ahead with polynomials, where I'm getting down to my prime factors. Okay? So one more, right? Factors of something like x to the third. We did this with radicals as well. It's just x times itself. There's really nothing fancy about x. There's really nowhere else you can go with it. With 24, you could break it down with 12 and 2 first, or 8 and 3, or 6 and 4. But with x here, it's just 3x's or 4x's, whatever the polynomial, the exponent is, just like we saw with radicals. But those are my factors. These are my factors. These are my factors. These are my factors. I cross these out to say, as an example, what happens if I don't want the ones with a 1 in them, right? But this would be a better answer here. But just to get a little reminder on that. Okay, 2 examples of like the opposite of factoring, right? Which is we do the same for polynomials, just writing that down. We do the same for polynomials as we did up here. So when we're factoring, we're doing the same idea, except it's going to have letters. It's not only numbers. Okay? Just as we saw with radicals. And I'll zoom up a little bit, just as so with radicals, right? So as I was saying in the examples above, the same idea with polynomials. Break it down into prime factors. Break it down as far as you can go. If you can simplify it more, do so. Okay? And then just as we saw with radicals, I kind of explained that up here. But let's do some multiplying of polynomials. Maybe you saw this before, maybe you didn't, but it's just helpful to see it both ways. If I say something like 2x minus 3 times x plus 4. If I were to say 2x minus 3 and x plus 4, we saw this. And I had said to FOIL. We did this with multiplying radicals. It was actually on a test and on a quiz. I said to FOIL them, and most people, most students had said they remembered, and it was you know, with the box method, or you did the first, outer, inner, last. I'll just show the steps. First, outer, inner, last, right? First, outer, inner, last. It just essentially means take this number, times it by both of these, and then take this number with its sign and times it by both of these. 2x times x is 2x squared. 2x times 4, 3 times x, and 3 times 4, right, with the 3 being negative. We'll usually be able to simplify a little bit. I can combine those two terms in the middle. How do I know that? Well, they're both an x term, right? We had done a lot of like multiplying and combining, but when we're adding, we need the terms to exactly match, right? Just as we had talked about when we were adding radicals. They both have an x, I can combine them. This has an x squared, this has an x, cannot combine. I need only x squared stuff to add together with x squared stuff. So that's polynomial multiplication. Even if I had something as simple as this, x squared times 2x plus 3, I would essentially FOIL, but really it's just distributing. 2 times x to the first times x squared, and then 3 times x squared, just as we saw with radicals. A 3 can't go into the x. There's my answer there. Nice simple problems here so far. If I were to multiply x plus 2 times something a little larger, like 2x squared minus 3x plus 4, just like I kind of explained it up here, you take the first term, times it by both of these. Then you take the second term with the sign, times it by both of these. I would do the same thing here. I'll do it in colors. The first term times by 1, 2, 3. So I would do that first. And I would get 2x to the third now, minus 3x to the squared now, plus 4x. So there's just essentially getting beefed up by x. Same thing with the plus 2 goes to all 3. So essentially this is like big foiling, or I just call it distributing. First term into all 3, second term into all 3. 2 times 2x squared would give me a 4x squared minus 6x plus 8. So here's 2, 2, 2. There it is. Just as we saw above, there are like terms I should be able to combine. 2x to the third, a plus 4x squared, and a minus 3x squared. Just give me a plus x squared, a negative 6x, and a positive 4x. And then I have that plus 8 on the end. Just looking at this now, we'll get familiar with it, but I have my descending order where I have a third power, a squared power, a first power, which obviously we don't see there, and then like a 0 power, right? We know that x to the 0 is 1, so like there's like my x to the 0, it's not there. Like 8 times 1 is just 8, it's really not there. And that's how we always want to write it, in descending power order. Those of you that saw multiplying before, very simple. Those you maybe saw up to here and never really saw something like this, treat it just like big distributive. One term into all 3, one term into all 3, then you combine. And make sure it's in this descending power order. I'll write one that I'll probably have you do for homework just because it's a little longer, but something like this, or classwork rather. Something like this. I'll start it just to show you how I would do it. Same thing I just said. First term into all 3. Second term into all 3. Third term into all 3. All right, so here's my x squared going into all 3 terms. and I won't write it, but you can do that later. My second term multiplying all three, and then I would get my last term multiplying all three. So I'd have like my red bunch, my green bunch, my purple bunch, and then just like I did up there, I would combine like terms. And again, I'll leave you this one to do for classwork or something, but that's the idea of this problem. Okay? Now, just getting into a little bit of factoring, because you'll have some of this for homework, and then definitely factoring, right? So just kind of taking a quick peek down here. A couple more examples. When we are factoring, exactly what I said, and again, I'm just going to try to keep this video a little shorter. Factoring is finding what multiplied to get the given product. Now, just as we saw up above with like the 6 and the 24 and the 3 I did, right, multiplied to get me to that number 6, or what multiplied to get me to that number 24, right? Same idea here, except these are polynomials. So for example, something like x to the third minus 3x minus 10, right? Example 1. What my goal is here is I want to find out two things. First is what multiplies to this back number, the negative 10, times the number in front of the x. Oh, sorry, my apologies. That should be an x squared. That should be an x squared. What multiplies to negative 10 times 1? Right, obviously with a lot of these beginning ones, there's just a 1 here, which we don't really need to worry about. But I take the number in front of the x squared, and then the whole number in the back, I multiply those, and I get a negative 10. I want to figure out what multiplies to negative 10, and at the same time also adds to negative 3. So I want to find something that multiplies to negative 10 times 1. There's my 1. And also adds to negative 3. So I start to think of multiplies. I start to think of factors of 10. Something like 5 and 2, or 1 and 10. That's really it. 1 and 10, there's no way it'll ever get me to negative 3. Never. But I can have 5 and 2 get me to negative 3. How? I need the 5 to be negative, the 2 to be positive. If that's the case, negative 5 plus 2, there it is. It gives me this, which is what I want. It has to add to that negative 3. Will negative 5 and positive 2 multiply to 10? Yes, it will. So that means I'm going to write 2 sets of parentheses. My x squared is going to go to x and x. And then I write these two numbers right here, negative 5 and positive 2. And these are two factors, two things that are multiplying. They're multiplying. And if I were to FOIL them, it would get me back to here. These are two numbers that are two polynomials, binomials, that when multiplied, FOILed, would get me back to here. Okay, just because for kind of quickness of time, this x squared tells me it's just x and x. Once there's a number in front of here, this will change a little bit. Okay, number 2, a different example. X squared plus 10x minus 24. Okay, again, I'm looking for two numbers that multiply to negative 24 times this number, which is just 1. So again, nice and easy. What multiplies to 24 and at the same time adds to positive 10? The sign matters, positive 10. So I'm going to start to think of factors of 24. Something like, all right, well, 1 and 24. Is there any way I could add or subtract these to get me to 10? No. Okay, what about 2 and 12? There's a way I can get to 10 there. Looks pretty good. Maybe I could do something like let's see, positive 10. So maybe something like 12 and negative 2. Okay, 12 and negative 2, if I add them, 12 plus negative 2, I get 10. It's positive, good. And if I multiply them, I get negative 24. Perfect. So those are the numbers I want. Again, 2 sets of parentheses. These two numbers, positive 12, negative 2. Because I just have an x squared, I write x and x. So I just have an x squared, I write x and x. Okay? Trying to see what the score of this Islander game is. Next one, number 3. Something like this. I'll make it a little bit repetitive. What about this? Okay, if I were to give you something like this, we just did this, Mr. Haas. I know. 1 and negative 10. You told me stuff that multiplies to that number times negative 10 is negative 10 and adds. But now I have a positive 3. So exactly what I had, except not a negative 5 and a positive 2, but a positive 5 and a negative 2 would multiply. So that means I would write plus 5 minus 2, right? So if I'm looking up number 1 and number 3, the only difference is this is minus and this is plus, meaning I want the 5 bigger to give me a negative 3, or I want the 5 bigger to give me a positive 3. Same idea. Okay, and here is another one. X squared. Making this one up. Okay, 2 numbers that multiply to negative 12 times 1 and that add to positive 4. Okay, so again, start to think of factors of negative 12. 1 and 12. Never going to add somehow to get me 4. No. 2 and 6. Oh, that looks like it can get me there. How do I do that? Well, I want the 4 positive, which means I need the 6 positive and the 2 negative. Here are my numbers. X and X. One's negative 2, one's positive 6. The order doesn't matter, right? Order doesn't matter. So that means I could say, or I could write x plus 6 times x minus 2. It's really the same thing. Okay, one more idea, and then some practice problems. A little longer of a video because I am leaning towards the assumption, which may be unwise of me, that so some of you have seen this before. There is something we could do with 2 terms, right? So if I have something like x squared minus 4, or something like x squared minus 9, right? Now there's no x term, right? No x term. So I can't really do the method I was doing up there. If I have 2 terms and I have a minus sign, right? If I have 2 terms and a minus sign, I can do this process right here. 2 terms and a minus sign. I'm going to write 2 sets of parentheses, just like I have on the ones above, x and x, because that's an x squared. I'm looking at the 4, and I know that the square root of 4 would be 2, so I write 1 positive 2, 1 negative 2. The reason being, for sake of time, I'll just tell you, if you FOIL, I'll do it a little fast, you would get the middle term to cancel out. Positive 2 and negative 2x would cancel. There's my x squared minus 4. So it's actually a very simple method. All I'm looking at is it 2 terms? 1, 2. Yes, it is. Is it a minus sign? Yes, it is. That means I'm guaranteed to be able to write x and x. What's the square root of 9? 3. One's plus, one's minus. Doesn't matter which one's plus or which one's minus. I could do something like x squared minus 25. Is it two terms? 1, 2. Is it minus? Yes. X minus 5 and x plus 5. Because what's the square root of 25? 5. One's plus, one's minus. X breaks down like that to x, and x squared breaks down to x and x. We don't know this yet, but we will. What happens if I have like x squared plus 4? You told me it needed to be two terms and minus. Because that's plus, we're going to do this later. But this is how you get what we had talked about a way while ago, imaginary answers. Or I'll say solutions. I like solutions better. But you're going to get imaginary answers here. So I'm not going to give you any of these right now, but just for now, I used to call these prime and then change it later. No, we're going to learn this, but just not right now. So we're going to try to do it all together so we can kind of just do all the factoring together. But that's the idea we're looking at here. X squared plus 4 is. It's not minus, so we don't know it yet, but we will very shortly. Okay? Then one more. What happens if I have something like x squared minus 8? Is it two terms? Yes. Is it minus? Yes. So here's my parentheses. Here's my x. Here's my x. One's minus, one's plus. But wait a second. What's the square root of 8? You're looking at that like, wait, it was supposed to be a perfect square. No. We spent a lot of time dealing with radicals and how to simplify radicals. We know that the square root of 8 is 4 times 2. I can simplify it to 2 radical 2. So that means I can write this as x minus 2 radical 2 and x plus 2 radical 2. You're going to get some of those. We dealt with radicals, and in years past, I don't ask ones like these because kids say, oh, these are hard. No. We have to remember how to simplify radicals. So you're going to get these all the time. Two terms minus, we can do it. It's not a perfect square. It doesn't matter. You know how to simplify that. And if not, you got to refresh because it's going to be asked. Okay? A little bit of a longer video. For those of you that have seen factoring before, maybe it went by a little quicker. Those of you that have not, maybe I did this a little fast for you. You can slow it down. You can rewatch it, and I'll give you a couple problems to do for practice. Okay? Very important concept because this is used for the next 3 years, guaranteed. Let's go, Islanders.